This video is for those of you that have looked at one sample and found an average from that sample, and you're trying to determine if that matches some expected value or some predetermined value that was already set forth beforehand. For example, um, every road has one at some point. You have a construction zone with much lower speed limits. So to see if the drivers were obeying those speed limits, a police officer used a radar gun to measure the speed in miles per hour of a random sample of 10 drivers in a 25 mile per hour construction zone. And here were the results. So he's only taken one sample. We're going to be looking at the average speed of these drivers. So this is a means type question instead of a proportion, since we're looking at averages. But we only took one sample and we're trying to compare it to this 25 mile per hour preset speed that they should be driving. Okay, so because we have only taken one sample, then we are going to be looking at a one sample test. And because this is a question about means instead of proportions, for means we use the t-test in order to get our evidence. Okay, so the first thing I'm going to need is a hypothesis. And the null hypothesis and the alternative hypothesis are both, remember, focusing on our parameter of interest. Now, we can put our data into the calculator. I'm going to go ahead and do that under Stat Edit. And if you have any old information in there, we just want to go up to the L1s, the L2s, the L3s, and hit clear. Do not delete your columns, and just enter your information. Since we've only taken one sample here, then we're just going to be entering that one set of information into L1. Okay. So now that I have my information in there, I can look at what the average of my result was. That average, since it's from my sample, is represented with an X bar, the statistic, and my calculator will do that for me. I can go to Stat, over to Calculate, run the one variable statistics on it, telling them that my information is in L1. You don't need a frequency list, and you can just calculate your mean to be 28.8. So what basically I'm trying to do with this test is say, okay, I know 28.8 is above 25, but could this just be a result of sampling variability where I just happened to get this for this sample? The next sample, maybe it would be below 25. Or is this result so different from 25 that I can really assume that all drivers are exceeding the speed limit in this construction zone? So for my null hypothesis, I want to focus on my parameter of interest, which is the true mean, the mu, of all drivers. And the first part will always be equal to. So what I'm going to assume from the very beginning is that they are going 25. And what I'm going to try to prove is they're actually driving faster than 25. So the mean would be greater than 25. This hypothesis, since we only did one sample, only includes that one mean value, and we're trying to prove something against this established beginning speed. Now, in order to run this test, we do have to meet certain conditions that I need to check. And the first condition that you have to meet for a test about means is that we do have a random sample. Now, for this particular problem, it is stated, and in your experiment, you won't have to do that because you're going to make sure that you've taken a random sample, and you can talk about what kind of sample you chose in this part. The second condition that has to be met is we have to make sure that this would be considered a normal curve. And there are a couple of ways that we can do that. If we know that our data is symmetric, then we can verify it that way. Or if our sample size is greater than or equal to 30, we can also verify it that way. Now, because this particular sample size was only 10, then I have to do it a different way. You should have 30 data values because I think that's set forth in your project. So I think for you, you could just put your sample size is greater than or equal to 30. Now, just in case it's not, then what you would have to do is you would have to check something called a normal probability plot. And your calculator will do that for you as well. So if you go to second and y equals, that's going to bring up your stat plot menu and choose number 1. If you just make sure that this plot is turned on and choose the very last graph beside type, this is your normal probability plot. And we need to include what data list my data's in. Now mine says L3 right now, so I need to change that to L1. And L1 is located in blue above the number 1 on your calculator. So I can hit the blue second key followed by 1, and that will change it to L1. Okay. I don't really have to change anything else. So to look at this graph, we have to hit zoom 9 to view statistics. And if you can look at this probability plot and say that it appears approximately linear, then we can assure ourselves that this is representative of a normal curve. Again, if your sample size is 30 or greater, you do not need to do this normal probability plot. You can assume that your data is going to be normal. The final condition we need to check is the 10% condition for independence, and that is based on your sample size of 10. If you multiply that by 10, you get 100. And I can assume that 100 is less than the population of all drivers coming through this construction site. We definitely have more than 100 drivers. So because this condition is met, or all the conditions are met, we can run this one sample t-test. Remember, because we only took one sample, and any test regarding means is a t-test, and my calculator will do that for me. So I'm going to go to stat, and I'm going to go over to test. I'm going to choose the one sample t-test. So be very careful here. You're not going to see a one sample listed, but you do see a z-test and a t-test. We are going to choose the t-test, so be very careful. We're going to choose number 2. And the first thing it's going to ask you is, do you have data or do you have stats? We have a list of data. We did not compute all of the statistics on that already. So I'm just going to use the data and hit enter. And the first thing it's going to ask you for after you hit enter is the mu naught, the mu sub 0, which is your null hypothesis. We were assuming from the very beginning that this was equal to 25. We're going to tell the calculator where our list of information is. That's in second L1, which is second 1. Frequency is always 1, and then I'm going to tell it what alternative hypothesis I chose. The alternative hypothesis I chose was greater than, so we're going to select the back option, and then we will calculate our test. So what we get is a p-value that is equal to 0.007 if I round that. And since that p-value is less than 0.05, which is our typical alpha level at a 95% confidence level, then I am going to reject the null hypothesis and state that we do have evidence of the alternative, in which I said the average speed is greater than 25 miles per hour. Okay. Now we could even support that conclusion with a one sample t interval. It's the same type of run, but we're going to do an interval instead of a test. So if I go back to stat, and choose test, and then I have a one sample t interval, which is just going to be a t interval, number 8. And my information should already be in there. We had data, it was in L1. We're doing a 95% confidence level because I'm testing out an alpha level of 0.05. Together, they're 100%. And we're going to calculate that value to go from 25.98 up to 31.62. Okay, so what this interval tells me is the true average speed in this construction zone falls somewhere between 25.98 and 31.62. Since 25 is not in the interval, and that's the speed I was comparing it against. Since 25 is not in there, that supports my conclusion that I think it's greater than 25. And the fact that all the numbers in the interval are greater than 25 also supports that conclusion.